Hello and welcome to this video series on using SPSS 26 on AU apps. This is going to be video 1 of a 4-part series. The overall roadmap, we're going to cover how to import data onto AU apps from your local machine. We're going to talk a little bit about the SPSS environment. We're going to talk about how to edit and recode data, run different statistical tests from the independent samples t-test, ANOVA, and regression. We're going to create some visualizations, as well as export output out of AU apps and onto the local machine. So for video 1, what we're going to do is we're going to specifically cover how to load data into SPSS on AU apps. I'm going to give an overview of the scenario, provide an overview of the SPSS environment, and go over how to create new variables and recode existing variables. So I'm going to go ahead and go into AU apps. Now I'm going to go ahead and have it start loading this. And while that's loading, I'm going to go ahead and give you an introduction to the scenario. For this scenario, we're interested in studying the relationship of the amount of corruption in a country and the quality of their economy. For this question, we are lucky that data already exists. We're going to be using the World Development Indicators WDI dataset, which is compiled annually by the World Bank. We're using data from a previous year and have simplified the dataset. But you'll find the full dataset on their website at http://data.worldbank.org/datacatalog/world-development-indicators. We're lucky because World Bank saves the data, which makes it really easy to open in the different formats. And typically you'll find a data set, for example, like old census data, which might take a lot more effort to transform into a usable format. And of course, there's never a guarantee that someone else has created the data that you want in advance. Often the first step in a research project is spending a long time looking up values to create the data set that you need. Within the WDI dataset, we're going to focus on variables specifically corrupt and GDPPC. Corrupt is an index of perceived corruption within the country's government. Citizens are surveyed and asked questions like, what do you need to plan bribes to start a business? Note that corrupt is actually reverse coded, so higher scores mean lower perceived corruption. The second variable is gross domestic product per capita, which indicates how well the economy is doing scaled for the population size of a country. For example, it might not be very interesting to note that Botswana produces less than Brazil overall, but it might be interesting to note that Botswana produces more per citizen than Brazil in 2014. Note that in using these variables from the WDI dataset, we have given the responsibility of determining what corruption and what quality of economy means to the World Bank. We have not operationalized nor picked out measures to measure these. So this kind of creates some potential issues in terms of if we are stuck with what was collected. We have also allowed the dynamic concepts to become really simple numbers. However, this makes us be able to move quickly to a later stage of analysis, which has its advantages. So what we're going to do now is we'll talk a little bit about the data. So I have it open up in Excel. This is essentially a tidy format, as well as sometimes called wide format. The first row within the CSV file, this Excel file, is the variable names. Notice how each one is all one word. None of them start with a number. There's no special characters. This is a requirement of SPSS, otherwise it will have some problems. A is essentially a string variable. Each country has its own row and it's not duplicated, so it's a wide format. And notice how there's a lot of these null values. This means that there's missingness in here. So I'm going to go ahead and minimize this. We're not going to talk too much about missing data, but it's always important to consider, especially with the default analysis within most statistical programs, is what's called list-wise deletion. So if there's any missingness on any of the variables of interest, that observation is dropped from the analysis. So you can go from 217 to a really small sample size quite quickly. So I went ahead and I opened up SPSS, and I'm going to go ahead and close out of this. We're actually going to import it from a .sav file, which Let me just go ahead and open this up a different way. So we have a .sav file here. That's our data set. It's an SPSS version of this, which has the labels we've already converted. So we're not going to import it directly from Excel. Now this is the main window for SPSS. To import the data, what I'm going to do is I'm going to go to File, click on Open, and click on Data. Now, right now this document is not actually our local machines documents. This is the Azure Cloud Virtualized one. So we actually need to go scroll down. It's going to look a little bit different on Mac. You'll see, if it's on Mac, it'll say eSchuler on MacBook or something. It's the Z drive. This is assuming that you have VMware Horizon correctly set up for sharing to your local machine. If not, please go back and do that. So I'm in my local machine and I need to find my desktop. I'm going to click there. And there is our data set, our cs.sav. I'm going to click on it and click on Open. Now you'll have a new box that opens up, which is your output. This is essentially everything you run, all your analysis, all your results, all your figures and tables. It's all going to be put into this new window. This is our data window. We have our data view, which is essentially like your Excel spreadsheet. Your first row would be a header, is now actually your variable headers here. We have our first column, which is our string variable. Notice the A next to these two dots. That's saying this is a string variable. It's essentially just an ID, an identifier. Now you see these kind of different symbols. These three dots mean that these are mutually exclusive groups or categorical data. With OECD member, it's a binary 0, they are not a member. 1 is they are a member. A continuous variable has this little ruler looking thing. And what we can also do too is if we click on this bifactored arrow 1A, there's actually value labels. So underneath those numerical of 0s and 1s, it says yes, no, or OECD member, not an OECD member. So you can kind of toggle back and forth in that. So what we can also do is we can go to variable view. And this variable view has all the information of each variable. It tells you the type of variable. Now SPSS cannot do anything with a string variable. It has to be numeric. You can also add as much detail as spaces here and labels. So I can actually click on GDP. I can double click in there, put in gross domestic product per capita. We have our nominal variables or categorical. We have our scale. If you're using Likert data, there is another option. We can go ahead and in that dropdown, there's Ordinal. So that's kind of bronze, silver, gold. So we can also see here with values. For OECD member, remember those toggling back and forth? If I click here and click on those three dots, it actually says what the value labels are for each one. We're going to come back to this in a little bit when we create a new variable too. So what we can also do is we can save a copy of the data set. I always recommend saving often. If you're just overriding it, you can go ahead and click on that floppy disk icon. If you want to save a backup, you can click Save As. And I'm going to go ahead and put this as CS 2020. And I'll put in 08. And notice when I saved it, it was still on my local directory for my local machine. So let me go back there and just to point that out again. So we're in desktop. This is my local machine's desktop, not the Azure cloud. There's the original one, and here's that new one that we're making edits to. Great. So what we're going to do now is we've already gone over, we've changed the data labels. So going for GDPPC and spelling that out. Let's go back to variable view. And what we're going to do now is we're going to go to corruption. And you know what? I want to make sure that this is clear. I'm going to put this as perceived corruption index because the perception is not in an actual measure of corruption. Great. So now what I'm going to do is I'm going to go back to data view, and corrupt is actually reverse coded. So we're actually going to change this now. So high scores actually mean higher perceived corruption. To do that, I'm going to go to this transform ribbon. I'm going to click on compute variable. Now target variable, we have to give it a new name. We're going to type out corruption 2. Under numeric, we're going to say 10 space minus space, and then take our perceived corruption variable here. And this is from the labels. If you want to change this to just the variable names, right click and change it to display variable names. Again, just you can toggle back and forth by just changing from variable labels to variable names. I'm going to take our corrupt variable, click on the arrow, so now we have 10 minus each country's corruption score. So if they have a 10, it's going to become a 0. A 9 is going to become a 1, and so forth. Now I'm going to go ahead and click on OK. There's also an option here where it says paste. If you click on paste, a new window is going to open up. This is Spss Syntax. So underlying all the point click options, this is the command that's running. If you press enter between here and put an asterisk, I can put in a note saying we are recoding, and end with a period, and then that makes it so it's no longer grayed out. Think of this as a syntax where it's just going to be, if you want to rerun things, and also keep a track of what you're doing, you can always use the paste option with comments. You just highlight this, click the play option, this output window is going to open up and say, okay, what did you do? And say, oh, okay, you recoded it. Now you don't have to use the paste option in syntax. I personally like it. That way I can always go back and rerun things really quickly rather than clicking through each and everything. So I'm going to switch back over to our data view. If I scroll over, we have our corruption2 variable in our original variable. If you add up corrupt plus corruption2, that should equal 10. And that's just saying, okay, we reverse coded 10 as the maximum, so if you add them together, it has to equal 10. Now it also has 2 decimal points. We're going to change that and add a label. I'm going to click back over to variable view. I'm going to change on our row 14, that's our corruption2. I'm going to change this from a 2 and click on the drop down to change it to 1. And I'm going to put this as perceived corruption recoded. And that looks great. So we've just recoded a variable. Now, one last thing we're going to do is we're going to recode a continuous variable into a discrete variable. Well, what does that mean? So think of it this way. Let's say we're talking about countries with a 5.6 and a 7.2 for perceived corruption. Recoded, of course. Well, that might not be as interpretable as saying that countries with high corruption or low corruption or medium corruption. Well, if we categorize this, it makes it easy to interpret. However, we do lose nuance with this because everything within a range, like range 0 to 3.3, assuming we're using mutually exclusive bins that are equally spaced, so from 0 to 10, 0 to 3.3, 3.31 to 6.6, 6.61 to 10, we're creating 3 separate bins. And we're saying everything within that bin, treat it as the same. So we're treating countries with a 0.5 and a 3.2 to be exactly the same for corruption, which we're losing variability with. So it comes at a cost. But if you wanted to do this, what you can do is click on transform, and we're going to go ahead and do recode into a different variable. I always recommend recoding into a different variable than recoding into existing. That way you always have the raw variable to go back to. I'm going to scroll down and find our perceived corruption recoded. I'm going to put that in there. And we're going to create a new variable. I'm going to call this corrupt underscore categ. And this is going to be short for corruption categorized low, medium, high, equal spaces. And click on change. If you don't click on change, it's not going to assign it to a new variable. So I'm going to click on change. So we're recoding the corruption to into a new variable. We've added our variable name and our label. And now you want to click on old and new values. So what we're going to do now is we're actually working with ranges. So we're not going to use this first option. I don't recommend using system missing or system reusing missing. That's going to import or try to add a new value that you're specifying for missing this. And that's not really generally a good idea within this. You also don't want to use all other values, because if using that last bin you click all other values, then if it's missing, it's putting those values in that bin too. So what I'm going to do now is I'm going to say range lowest through value, and I'm going to type in 3.3. Under the new value, I'm going to give them a 1 and click on add. So that's going to say, okay, what's that first bin? The first bin is going to be the lowest value through 3.3 and assign them all a 1 in this new value. Now our middle value, I'm going to go ahead and put a range. I'm going to type in 3.31 to 6.6. Now corrupt is only a single decimal point, so I'm going ahead and just adding that specificity here. That way these are mutually exclusive bins. No value is going to be in between bins, and none of them can be in two bins at the same time. So that's our next bin. I'm going to assign all those within this one a 2 and click on add. And finally, I'm going to go through range value through highest. I'm going to type out 6.61. And I'm going to give that a value of 3. So these are our 3 bins. Lowest through 3.3, give them a 1. 3.31 through 6.6, give them a 2. 6.61 to the highest, which is 10, give them a 3. I'm going to click on continue, and then click on OK. So here it ran it. And if I go back to our data view option, here's our new corruption categorized. High, medium, and low, which we haven't added those labels yet. If we toggle, it's still numeric. So what I'm going to do now is notice there's also missing here. So if they had missing here, we can't compute it. So we can't compute something that's missing without any other specialized analysis. I'm going to click on variable view, and I'm going to click on values. Click on those 3 dots. Now I'm going to do is say, okay, if they have a 1, call this low corruption, and click on add. If they have a 2, let's call this medium corruption. Click on add. And finally 3, we're going to call this high corruption. Click on add and then OK. So we've added variable labels there. Go back to the data view icon. And now when we toggle it, we have those value labels. This concludes video 1. We're going to pick back doing some questions about mean of a variable next.